Hey, if you're like me, you probably have a few hundred apps on your mobile device. Now, consider that your mobile probably has less overall memory than, say, your laptop. So how can you have all those powerful apps on your mobile with less overall memory? Simple. The mobile apps aren't necessarily processing the data locally. They're basically just exchanging that data back and forth with the server or the cloud via Application Programming Interface, or API. APIs themselves are not new. Applications and data centers have been using APIs for years to exchange data among themselves, internally. What's different, what's on your mobile then, are external APIs. And in the past few years, there's been an explosion of external API data. What we're really talking about is data formatted into discrete fields, such as your name, your location, your last request for an Uber. And these external APIs aren't just on your mobile devices, they're on all your devices.
A Peloton? Give it up for our first time ride.
All right, first ride. I'm a little nervous, but excited. Let's do this.
During the pandemic, sales of the home fitness cycle Peloton grew massively. Given its popularity, it's natural that security researchers would want to take a look. And in May of 2021, researchers disclosed that the Peloton's API authentication was broken. With that, an attacker couldn't necessarily intercept the data, but they could query the Peloton API to get user data that they weren't supposed to. In other words, Peloton suffered from an API vulnerability that could potentially lead to a massive data breach. Here's Eric Wild and his guest, Francois Lascelles, on Getting APIs to Work podcast discussing the Peloton vulnerability.
To me, the storyline was interesting, right? So when it was reported, I think in late January, it was completely open, right? Like you said, right? No authentication at all because, well, we didn't tell anybody about it.
Yeah.
And then they reacted actually relatively quickly within a couple days and closed it. But they closed it so that now you had to be a registered Peloton user. So, now you had to be one of the privileged millions who can freely create Peloton accounts. So even though it was authenticated, then that was not super helpful, I would guess.
Yeah. Yeah, and this is a huge lesson in API security, right? Hackers are also users.
So, if a hacker wanted to, they could register as a Peloton user and then, with a few tools, obtain all the user IDs, instructor IDs, group memberships, and whether or not somebody was in a studio. This information by itself might not seem very problematic. But the Peloton API also contains your location, your workout stats, your gender, and even your birth date. Okay, that's starting to get very personal. This raises a serious question. How many apps today are vulnerable to leaking API information? How might future API-based data breaches work? For that, I called upon an expert.
I'm Jason Kent. I'm the hacker in residence here at Cequence Security.
The work that Jason does for Cequence, as in the word sequence but with a capital C at the beginning, is helping his clients see where their security needs to improve.
I play an adversarial role with our clients. So if they're not being attacked, I attack them. And if they are being attacked, I break down how it's happening and how we can stop it.
That kind of makes Jason a one-person red team.
I don't know, maybe purple team a bit. I play kind of both sides of the fence, but yeah, definitely do a lot of adversarial inspection of, any kind of traffic endpoints that I find at our customers.
To be fair, APIs are also used in web applications, which you access through your web browser. And we've had our fair share of security concerns with those. In fact, to keep track of all the potential web application vulnerabilities, the Open Web Application Security Project, or OWASP, publishes a list of the top 10 web application security risks. Fortunately, one by one, we've been knocking each one of the flaws further down the list. Well, it turns out that OWASP also publishes a list of the top API security risks. But how many developers, in the heat of the moment trying to get their app into the App Store, are even aware of the API Top 10 list?
I was recently commenting on the Peloton breach, and I thought, well, how boring is that? Like that. I mean, they got all the data out and they could see anybody's data and stuff, but the attack was so boring that, I bet they didn't think it was going to work when they hit go. And And that's kind of how it is with APIs. When something is broken, something out of that API top 10 isn't there, it just all comes flying out, you know?
Given our current digital environment, just how powerful are APIs in terms of external data exchanges, and how are they different from web applications? And if they're so critical these days, then why haven't we been paying more attention to securing APIs? I mean, how hard is it even to hack an API? Apparently, it's not very hard at all. Welcome to The Hacker Mind, an original podcast from For All Secure. It's about challenging our expectations about the people who hack for a living. I'm Robert Vamosi, and in this episode, I'm discussing the importance of APIs in our digital world, the consequences of misconfigurations within APIs, and how you, yes, you, can even start hacking APIs in your spare time. So, for this episode, I probably need to set the landscape. API is an example of where I think I understand something, but then I come to find out there's a lot more to it. There's always a lot more, right? So, at a very high level, when you use application on a mobile device, that app connects to the internet and sends some data to the server. The server then retrieves it and interprets it and performs the necessary operations on that data and sends it back. The app on your mobile device then interprets that data and presents it on the screen. Again, at a very high level. That's what an API does. A shorter definition, APIs are where you define and perform operations on information that is shared with another computer or system.
We kind of discuss this as north-south or east-west traffic.
APIs used inside data centers, that's what's known as east-west traffic. North-south traffic, then, is data coming in and going back out, and that's what's grown in the last few years, and grown by a lot. When you open a browser, you're working with a web application on a server somewhere. Both web applications and the mobile app actually talk to the same API. That's where it gets confusing. It's like having a shared kitchen with two restaurants. Mobile apps are just rendering API data without all the bells and whistles that you might find with web applications. So, your high-level takeaway? Perhaps we can say that mobile apps are different from web applications in that they primarily use APIs.
It's a little bit of a borrowed term, right? Inside of software, there are APIs that you call, into libraries and stuff to move things around. And we've moved it out into the application space as kind of a way to go get data, a way to communicate between two systems. So it's typically computer-to-computer communication. Some of that's manifested by user input, but usually it's just simply I make a request for some data on some endpoint on a web server and it sends me the data back. Usually this communication happens in some kind of data language like XML or JSON or something like that as the transfer.
An API, when you get down to it, is just structured data, kind of like XML. Kind of like JavaScript object notation, or better known as JSON. Think of it this way. It's like filling out a Google Doc, and all the data that you enter into the blank input spaces becomes the API traffic going back and forth. Only it's a little more complicated than that, especially if you've got multiple data exchanges. Realistically,
all it is I've got my mobile application, and in order for me to get my information out of my bank, I log in. That login is going to happen over those API channels. And then it's not going to send me code like it would in a web application where it'll send me the page to render. It actually is already rendered in the mobile app. All we're doing is filling out discrete data fields. So account balance and, do you want to transfer, that kind of stuff. It simplifies that communication.
Okay. Even with this technical definition, APIs may still be a little hard to conceptualize. So, maybe a concrete real-world example is needed.
I like to use Uber as the example when I talk about this, right? When I say I want a car, it's got to communicate to the map services, it's got to communicate to my credit card services, so there's this traffic that's going all around happening from their servers, right? And then displaying back to me. So all of this communication is happening at high speed, and we don't want to play with moving JavaScript around or sending HTML to render. What we want is just the data to move, right? And be as quick as possible.
Imagine that you've arranged your life so that you can be online to get the tickets to a concert the moment they first go on sale, or better yet, a pre-sale the day before the general public gets access. So there you are at your laptop, logged into the ticket website, waiting, and then the countdown clock reaches 0. Your adrenaline fires up, your mouse hand tenses into position, the screen lights up, but the seats you want keep disappearing inhumanely fast. And then, just as suddenly, within a matter of seconds, it's all over. The concert is completely sold out. What just happened?
If you look at anybody that's selling PS5s or selling tennis shoes or any of those, hot stock drop items where there's only a few available and stuff, everybody complains about the bots, right? Well, the bots are doing everything on the API layer. They don't go through a website anymore. If you've instrumented your website to keep the bots out by putting up a waiting room, you're only keeping out your customers. The bots are hitting you on your mobile app for sure. That's how they're going to be doing it. We have lots of customers that do hot stock drops, and we see the APIs light up, all the cart creation and people logging in. It just goes crazy right before the drop. None of it happens on the web. It's all happening on the API layer.
This really was not an attack, not in the classic sense. So Jason, he's seen a lot of bots use the site's data in the APIs. In other words, as a human patiently waiting on the web application on my browser, I didn't stand a chance. I think part of the problem here is that people often have really great ideas, but in isolation. They say, hey, maybe there should be an app for that. And then someone else says, yeah, let's build one. But they've really focused on the convenience. And maybe they even use some sort of app kit or framework to get started. So they really don't get to the security part, if ever.
In general, yeah, they've shot this out there and said, look how much easier, look how much faster. And every time we do that, I swear, every time we do that, we end up with security problems. And we're really living in that world right now. You're seeing guy breaches in the news, aside from ransomware, which is happening in a different way. But when you see pure data breaches, pure data being exfiltrated out of an organization, you're seeing it happen on the API layer just simply because the security is not harder. It's just you got to pay more attention to it.
So it's this lack of somebody who knows security. And I'm sure the internet-connected toothbrushes are in that same category, along with all the other Internet of Things products.
I'm imagining that everything is, Amazon, Azure, and I think Google Cloud now have you can fire up an IoT, endpoint version of their product. They make it easy for you to make an IoT device and then have a backend service that it can work against. Which those frameworks tend to make things better, but they're still reliant on you're going to write code.
Sure, there are a lot of shortcuts, occasional errors. Developers, after all, are merely human.
And you're going to do things to make it easier for yourself. I've often said, there's no more persistent code than temporary debug code. You're going to make changes to make it easier for yourself, and they're going to persist and cause you problems.
So that's what an API is. It's structured data that's just in time created and exchanged with another system so it can perform an operation, such as display the availability of Ubers in your area or the specific Uber that you have hailed. So this is important data, and data that could lead to data breaches more and more. And all this sounds familiar, like we've dealt with this a decade ago, didn't we?
Yeah, and in fact, I'm often lately quoted as saying we're looking at web app security in about the 2009 timeframe. So all of the things that were happening around 2009 in web is now happening on the API attack surface.
One of the classic examples of where API creation often goes awry is with the Internet of Things. Let's make some toothbrushes connect to the internet. Well, maybe we shouldn't. Because as a toothbrush maker, I know about bristles and I know about grips, but I don't know computer security that well.
You know, it really surfaced itself to me when I started looking at the stuff I'd plugged into my house, right? I really wanted to understand, you know, are all these new things secure? What I found out was that's not the case. Their security is really an afterthought, and especially when you're talking about these communications that no one really understands, right? This API communication, you can't see it. And so they, you know, kind of ignore the security features that need to be there, feeling that it's obfuscated enough, you know, it'll be easier to just overlook.
So a couple of years ago, Jason started looking around his house for things that could connect to the internet, specifically things that required that he install an app. He settled on his new Chamberlain garage door opener.
It was a Chamberlain, yeah. So I bought this, well, I bought a box to plug into my garage door opener, but I'd put a new garage door opener up, and one of the things they offered was you could put a box on there that would control whether it goes up and down, and it hooks to your, you know, your internet connection. And basically, you get an app on your phone, you push open the door, it opens the door. You know, this is a company that makes a machine that picks my door up because I'm too lazy to get out of my car when it's raining.
So a lot of companies are very good at the thing that they do. So you make a garage door opener, and you've been doing it for over 50 years. But do you know computer security best practices? Probably not.
You know, that kind of company probably doesn't have a real deep security research team associated with them. There's probably not a lot of folks around interested in that. And so I thought, well, this will, you know, what does somebody who's just entering this IoT game, you know, what are they up to? What are they doing inside of here? And so
we've seen this movie before. In fact, we already know how it's going to end, but I'll let Jason tell it.
I sat down in my driveway and I hooked my phone up to my computer using an Intercept Proxy.
Intercept Proxy. That's where you deliberately hijack the data before it reaches the internet. In this case, Jason had the data go from his phone to his laptop and then to the internet. While on the laptop, a tool such as Burp captured and analyzed the traffic. There, Jason was able to manipulate the traffic before it reached the server.
I opened a door, I closed the door, so I used the service the way you're supposed to. And then I started looking at the transactions, and the underlying API communication was very simple. Simple device ID. I'm requesting this device, goes to open, right? And so there was a device ID JSON element, and there was a door position element, 1 or 0. And they did a good job, and that 1 was open and 0 was closed.
So the API had 2 JSON elements. One element to identify which device you're talking to, its unique ID, and the other element to tell the device what to do, open the door or close the door. It's not rocket science. And yet, a few of you are probably saying, well, what's the worst you can possibly do with just those 2 elements, right? Well, turns out a lot.
I started calling friends of mine, and I said, do you have one of these things? And I got lucky. A friend of mine in San Francisco had one. He's, you know, quite computer savvy. So I said, hook up Intercept Proxy and tell me what your device ID is. And he told me, and I sent in the next request was his device ID, and I requested the door go open, and he's like, you opened it. and you know, there it was. I'd figured out that I'd plug my house into this thing that now anyone can come in.
So just to get clear, this isn't the fob that you put in the visor of your car. This is an app that you download and install on your mobile device.
And importantly, it's an app that you install that you can, you know, now my children are older and they all have phones and cars. So I can send them, you know, just a simple invite string. They install the app and they can open and close the door. If I had somebody delivering a package while I was out of town, I could invite them to come. And so it is a very convenient thing. I'm sure the convenience was well overlooked from the security implications of, you know, you can open my garage and grab my chainsaw and do whatever it is that you want to do. You know what I mean?
Once a problem is found, often the work of a hacker is not done. Sometimes reporting the vulnerability back to the company is hard. Of course, Jason reached out to Chamberlain, the company that makes the garage door opener he was using. Fortunately, they were able to work with him on it.
Yeah, they have. And they secured it very quickly. They saw right away that it needed to be done. I could easily write a script that opened every one of the subscriber doors, right? That would have been, the shenanigans level in that's pretty high, and I would have enjoyed that. But I wanted it to be secure, and I don't want people to know that it's not secure. So I impressed upon them that I wanted it fixed.
Yeah, that seems simple enough. Call them up, tell them the problem, and they start to fix it. Only that isn't what usually happens.
Having said that, have you ever tried to call random company and tell them their product isn't secure? It's not an easy thing to do. And there is no one answering that call. There isn't anyone on the line when you try to get a hold of them. It took a lot of browbeating and finally saved the day. And I got a hold of somebody.
As we said, a garage door company is not known for its computer prowess. And yet, more and more of these IT devices are just, we'll add this feature and we'll make it so it's more convenient. But then they have no clue about the necessary computer security behind those statements. And more often, they don't even have an abuse line for you to report it if there is a problem.
Right. I actually spun 2 talks out of this thing. I spoke at several B-sides, and I even keynoted at the RSA in Abu Dhabi about being curious and taking things apart. But I also started a talk on how to be ready for a researcher to call you. Because there was no way, there wasn't an abuse at chamberlaingaragedoors.com or anything that I could report to. And in fact, they're part of a multinational conglomerate. The people that I ended up talking to were from the parent company. And it's not called Chamberlain, right? Like it's a completely different thing.
Right. So a lot of these companies are actually divisions of other companies. You're a hacker. You don't have the time to map out every merger and acquisition. You just want an abuse contact so you can give them your proof of concept and get the problem fixed. How hard is that?
And so I started speaking to organizations that build IoT products to start doing things like, just stick a couple of lines in your server that have headers in them that say, if you find a security problem, tell us here. Because that's where the researchers are going to see it, right? Or create a humans.txt file instead of a robots.txt file. Like there's plenty of different ways to approach this, but you have to have some way for the researcher to tell you, hey, I can turn the hot water heater up so high that it'll explode. You got to be able to have that come in.
And it's not just cute gadgets in our home. It's true with whole industries as well, such as automotive. A few years ago at DEF CON, Mark Rogers, now at Okta, and Kevin Mahaffey from Lookout Mobile demonstrated how they could hack a Tesla Model S. They did so by hacking the onboard infotainment system, but by using Tesla's own legitimate APIs.
This is kind of like the vehicle equivalent of stored procedures. The car has a bunch of commands in the gateway that it will let you send commands to, and that it will then relay through the CAN bus, and anything that's not part of that, you can't send through. That potentially means that malicious traffic cannot get through the gateway. Now, that doesn't say that the gateway can't be compromised. We did not go that deep into analyzing it, and we certainly saw signs that there are security issues that we would like to look at. But as a basic design, what it means is, unlike with a certain other vehicle, when the infotainment system gets compromised, you cannot immediately send CAN frames that do bad things to the car.
And again, that's huge. I don't think you can say the same thing about many other cars out there. The fact that there is this strong isolation is extremely important. So now we can control a number of things. Basically anything that the CID does, that touchscreen, we can now do. And now the question is, so there's no way, as far as we can tell, to inject CAN frames, from at least so far, onto the vehicle network, but we can use the legitimate API. And the question is, can we abuse the legitimate API? Here's the things we can do. What do you want to try? So again, we set up our SSH tunnel between a CID and a server.
And of course, the one we want to try is like, if you're going to do a remote cyber attack against a car, what's the thing you're going to do? It's going to be the most catastrophic one, right? So we found a combination of API that would allow us to basically tell the car to shut off key parts of itself, to shut off the power rails, to switch off the screens, in fact, to shut the computers down. And we tried that.
When Mark Rogers did his hack, it was on the fact that the Tesla was looking for a specific Wi-Fi access point, and he just spoofed it and then could communicate over the APIs on it. So when you look at how people are building things, these small data exchanges are really how it's working and makes it work very quickly. But once you break into it, it becomes a real problem.
Another industry that could be directly affected is financial services, with all the mobile banking applications that are becoming more common today.
I actually have banks that are experiencing problems with, well, we want people to be able to sign up for a new account, and we want people to put in loan applications. Well, what happens when a bank that normally processes 50 loan applications a day is getting 5,000? And they're coming from 50 of them are legitimate, right? And 4,950 of them are from offshore, coming from proxy networks, all that kind of stuff. Those APIs are getting attacked just as much as anything else. And the way it's happening isn't by intercept proxies, it's by tearing apart the apps like I was talking about. Most banking applications have pin certs, and they're a lot harder to look at.
Certificate pinning forces your client app to validate the server's certificate against a known copy. It's a way of making sure that the party that is receiving and sending your data is the party that you want, not some proxy or forgery. Cert pinning should be mandatory API best practice, but alas, it is often not.
You've got to have some pretty good phone foo in order to write code to make it so that it'll bypass that cert pin. But I can go look at the app and just tear it apart and see the endpoints.
So how do you tear apart an app and see what's going on inside? How do you start to hack? Jason uses Burp and Zap.
Yeah, so I'm a Burp Suite guy. I'm also a Zap guy. So, but this is sort of like being both an Emacs and DIM guy, right? I do more in Burp than I do in Zap, but Zap has a lot of stuff that I really like in it. But so I already have a Burp license. So all I did was, in Burp, you can tell it to listen on a specific interface, or you can tell it to listen on all interfaces. And that's all I did is I turned on all interfaces. And then in my mobile phone, in your wireless settings, there's a place to put in a proxy. And I just put in my laptop's IP address, right? And a port. Since it's listening on all interfaces, it picks up all the traffic. In their particular case, and what I find is often the case, is the certificate wasn't pinned. So I didn't have to do any tricks. I could see the communication wide open. It let Burp terminate their services. I had the CA installed on my phone. So I, in essence, would send the packet encrypted. Burp would then decrypt the packet and let me look at it. And then it would send it on encrypted again with the server. And so being able to peer into the middle there let me see all of the data exchange.
So looking at his packet captures, that's how Jason was able to manipulate the garage door.
Yep, I was able to see all of the data exchange going back and forth because I'd ripped open the middle bits there. And I could eventually say, all right, this is the pieces of data that I need to manipulate in order to make the door open or close.
Burp requires you to have a license. Zap, which stands for Z Attack Proxy, is open source. It's a web application security scanner. Most people may not have heard of Zap.
Yeah, so it's the OWASP project. A guy named Simon Bennett was the leader on it. I think he's still leader on it. He's changed jobs, but he got hired at Mozilla a few years ago, and they hired him to write Zap. In essence, what they were hiring him framework to automatically test their software. And so it's had a lot of funding behind it. It's had a lot of development behind it. And it's a great product. There's tons of features in it that I really like. You can get a free version of Burp and use it. Either one is fine, but they're very it's like knowing Python versus Perl. There's, you're doing the same things, but man, it's a different language. And that's kind of how it works. So you kind of learn one and stick to it. They would be one of the two tools. They'd be one of the things I'd say they start with.
With Burp, there are specific tools that Jason uses, such as Repeater and Intruder.
I do a lot of stuff in Repeater and Intruder and Burp. Repeater just lets me replay, and I can manipulate things and replay and manipulate and replay. And then Intruder lets you iterate. So if I wanted to use Burp's Intruder to open every garage door, it would have been pretty easy to just say, this is what I want you to change, and start counting up through the numbers.
There's also a third tool that Jason uses. This one is designed for Android apps.
There's another tool out there called APK Tool. And if you're having trouble intercepting, and because they pin their certs or any of the other weird things they can do to make it so that Burp and Zap don't work, the APK tool will let you download the Android application for whatever you're looking at, and it'll tear it apart and it'll give you the API endpoints. So from there, you can start testing.
Android apps are based on Java. iOS apps are based on C. So is there equivalent technology for analyzing iOS apps?
There is. It's just harder to break. It's a lot easier to do stuff on Android. If they have an iPhone app and an Android app, I'd rather go there. It just lays out a lot easier. The APK file is in essence a big XML file. So it just lays out a lot easier to go pull stuff out of it. C's compiled code, so you have to do a little bit of decompilation in order to see it. I don't have that kind of foo, so I lean on the easy one.
That said, there are some fun and games to be had with the back end, however.
On the back end, the developers are starting to do more with frameworks around APIs, so self-documenting frameworks. And I'll let you in on a little bit of research I'm doing. Those frameworks auto-publish the documentation for APIs. We're starting to see attacks against those endpoints.
So it's a configuration issue. Someone gives you a framework, and if you don't understand it, someone who does then could find where you are vulnerable.
What I mean by that is if you have an API that's say /v1/authentication, there's probably a /v1/docs. And in there is a manifest of all of your API endpoints, all of the security associated with them, etc. If you're into APIs and you're self-publishing docs, please stop doing that. There are scanners now that are reading those docs and then attacking you after that.
Fortunately, the state of API security is getting better. Jason spoke at RSA Abu Dhabi in 2016. Since then, the subject of API security is gaining traction at conferences. It's becoming a track that is something more and more people are interested in.
If I put API in the title of a talk, I usually get it accepted anymore. And it's usually a well-attended talk. And that kind of goes across the board. Doesn't matter what it is. Developer conferences, pure security conferences where it's like net security focused. If you're going to be talking about APIs, somebody has this problem. They're probably somebody in the organization standing there screaming. And they want to learn, how do I convince my boss to pay attention to this? Or how do I get the dev teams to stop whatever? And so it's becoming a thing.
OWASP also produces the API Security Top 10 list. These are the common weaknesses that are seen out in the real world. The 10 ranked by severity and prevalence.
It's pretty accurate. The first two are definitely the right first two. There's broken object level authorization and broken authentication are the first two. Object level authorization, that's when I'm logged in and I look at your profile and can edit your profile, right? Like I'm not authorized to do that, but it's broken, so I can. Authentication is, whether or not I'm authenticated onto the service. And I've been finding through a bunch of research that I've been doing lately that a lot of people have figured out how to do authentication in a way that you can just undo it.
I was previously working at an identity company. Authentication, a vital aspect of identity management, is a lot like encryption, and it's probably something that you don't want to write yourself in-house. Get some experts. Contact an organization such as ID Pro for references or for resources. But then again, as with encryption, you still find people who just, for whatever reason, manage to roll their own until it breaks.
Spend a lot of time looking at traffic going against APIs and the traffic that comes out of them. And I alluded to this earlier. There's so much information that comes out of these things. Like I said, I was looking at this forum group and I just simply deleted the authentication header and I was authenticated. And just deleting the auth header let me see everything. And it's, yeah, so the face that you just made is exactly how I look when something really easy is done. And then I remember it's in the API layers. Folks are just not looking at this stuff. And that's indicative of where we are. The OWASP API Top 10 came out in December of 19. So we're not looking at, real long run with this thing. And we're seeing that it's very basic stuff.
So what can be done about this? We have the OWASP Top 10. We seem to know how to prevent this from happening, and yet it continues. It seems that we should be able to stop insecure apps at the App Store, before a user installs it. I mean, we've all heard about the walled garden and how great it is. Apple supposedly won't let apps onto its App Store unless it passes rigorous testing. Apparently, APIs are not among the tests conducted, or at least what's currently being done is not strong enough of a barrier. Shouldn't the app stores be doing more?
I would like for them to, right? I would like for them to come up with a way to say, all right, you got to meet this spec. And really, I'm one of those guys that constantly says, compliance isn't security, but security will lead to compliance. But if there's only one thing that's driving you to make decisions and that's compliance, then please bring it. We really need something that says, all right, your API should have at least this minimum mark.
And standards typically only set a minimum baseline. You really need to go beyond them to consider yourself secure. So yeah, let's see some API standards, if not best practices, enforced by the app stores. Jason's seen a fair amount of stuff that probably shouldn't have passed.
We see, TMI and APIs all the time. They're constantly sending us back these massive JSON objects that have nothing to do with anything. What we want people to do is look at what traffic that they're having going in and coming out. What should that traffic look like? And what should the person next to you be able to do with it?
That's where the API Top 10 security risks come into play. So what are they? Coming in at number 1 is broken object level authorization. Object identifiers provide access control. Therefore, object level authentication checks should be considered at every function that accesses data sources. Coming in at number 2, broken user authentication. This is what broke for Peloton and allowed virtually anyone to access the data until they patched it. Whenever you're compromising a system's ability to identify the client or user, you're compromising the API security overall. Number 3, excessive data exposure. This is the TMI that Jason has seen in the wild. Unfortunately, developers still tend to expose all of the object properties without considering their individual sensitivity. Number 4, the lack of resources and rate limiting. Remarkably, APIs sometimes do not impose restrictions on the size or number of resources that can be requested by the client or user. This can lead to a denial service attack or otherwise allow a brute force attack on authentication. Coming in at number 5 is broken function level authorization. Without sufficiently complex access control policies, attackers can gain access to other users' resources and/or administrative functions. Number 6, mass assignment. Binding client-provided data to data models without proper properties filtering can allow attackers to modify object properties they are not supposed to. Number 7, security misconfiguration. Insecure default configurations can lead to verbose error messages containing sensitive information. Number 8, injection. Here, the attacker's malicious data can trick an interpreter into executing unintended commands or accessing data without proper authorization. Number 9. Proper assets management. APIs tend to expose more endpoints than traditional web applications, making proper and updated documentation highly important. And finally, number 10. Insufficient logging and monitoring, coupled with missing or ineffective integration with incident response, allows attackers to further attack systems. That's the OWASP API Top 10 list.
If you can nail down a few of those things, authentication, being able to bypass that authentication, being able to look at someone else's profile, et cetera, then we start getting to the point where the top 10 for OWASP API security will move, right? We did it with the web security top 10. There's also one for web security. There are items that have fallen off of that and now you don't see CSRF on the list.
That's a great point. Crosssite request forgery, where an attack forces a user to execute unwanted actions on a web application in which they're currently authenticated, have largely diminished, in part because of the attention of the OWASP Top 10 for web applications. Maybe we can get the app stores to do a little bit more around API security. Hopefully, by us talking more about the need for API security, we can start to make some of these flaws diminish in number as well. I'd like to thank Jason Kent from Cequence for taking the time to talk about API security. You can also find his work on dark reading and threat post. The HackerMind podcast is brought to you every 2 weeks, commercial-free, by For All Secure. For the HackerMind, I remain just another programmatic data exchange, Robert Famosi.